Welcome back. We are now on problem number 17, TEKS 8.3c. It says triangle ABC is dilated with the origin as the center of dilation to create triangle ABC prime. Which rule best represents the dilation that has been applied to the triangle ABC to create triangle ABC prime? Okay, so what I'm looking for is I'm looking for a rule. The rule needs to represent this dilation that happened, okay? So what I have to identify first, guys, is which one is new and which one is old, okay? Based on little apostrophes that I see next to my A, B, and C, I know this is going to be my new triangle. Because this A, this B, and this C do not have an apostrophe, this is going to be my original shape, meaning I went from big to small, okay? Before we go any further, let's go ahead and let's label our triangles. Let's move this up, right? Well, I guess we can write old first. This is being a little bit sensitive. This is my old triangle. And let's go ahead and label our new triangle. This is my new triangle. I got smaller. Okay. So, based on what I know about dilations, okay, I know that in order to find the scale factor in which I dilated the shape, I need to use the new points over the old points, okay? So to do so, the first thing I'm going to do is I'm going to identify a perfect set of ordered pairs, okay? We're going to then identify a perfect set of ordered pairs for the old and new triangles alike, all right? So what that means is I'm going to use letter C. When I see letter C, I have the ordered pair of 6 and 2. So what I'm going to do is for my old, I'm going to put in a 6 and a 2. Just keeping track of what my X and my Y value are for that point. Okay. Now, because I've used C, I know that I have to use C prime. Okay, so let's look and see what C prime is. C prime is 3 and 1. So I'm going to put in my ordered pair of 3, comma, 1, close parentheses. Now, you don't have to do it for both, but no matter what you do, you're going to get the same answer. It's going to work out either way, okay? So I know that my new values for my X is a 3 and my old value is a 6, okay? So what I'm going to do is I'm going to do this. I'm going to write equals. I'm going to have for my new value a 3. Because I used an X value, I also have to use an X value for my old value, which is a 6. Now guys, just some simple math and simplification lets me know that this is going to be a grand total or a reduction of half. This half can also be written as, or 0.5, if you like decimals better, okay? What I just found was a scale factor. I found the rule to what I'm looking for, okay? These is using the X values. This is a 3, this is a 6. Guys, without plugging anything in, if I put a 1 over a 2, it's already half. They equal the same thing whether you use the X values or the Y values. You're going to get the same thing, okay? So what I'm going to do now is this. I need to make a rule. Generally, when I have a rule for this, it's always written in some way, shape, or form like this. So I'm going to have X, comma, Y. It's always going to start like this, all right? The next thing you'll have is an arrow pointing to the scale factor being plugged in. In this case, I'm going to have a half or a 0.5. I'm going to use 0.5 times X, comma, 0.5 times Y. What this means when I see it is that I need to multiply all of my values for X by 0.5 and all of my Y values by 0.5, okay? Again, half and 0.5 mean the same thing. So now let's go ahead and let's see which rule matches what we just found. It can't be A because it's a scale factor of 2. That means it's going to get bigger and not smaller. It can't be B because X plus or minus something means a translation. And it can't be C because negative times X and negative times Y is some kind of rotation, reflection, or transformation, all right? So I know that my answer is D, and it did match up with 0.5x and 0.5y. Thank you so much for watching. I hope you enjoyed the video. Spider-Man, tell him. Well, that's not Spider-Man. Peace out.